Okay, the one question I had is the tools that you had been provided with by Gabriel.
Yes.
Are you gonna provide them to us as well?
Yes, because the tools that is available is here, and it's a lot of tools. And when I just this morning checked, there is quite a discrepancy between that tool library and what is actually available here. So I will make sure that each of every tool available here is in a Fusion 360 tool database, because then things get so much easier if you can like plan ahead and you know what the diameter is, because the diameter will define you can like you perhaps saw in the you can simulate, and when you simulate you can see that, oh, okay, this is not as precise as I would like. I would like a smaller diameter, but then that will take time, and you can take that in consideration. Right now we only have it's only this in the tool dataset library, so we will be using this. Do you have another question? You said you had one, so
yeah, that's it.
Yeah, okay, perfect. You, with the risk of misstating this, you book the CNC by contacting Anna. Because last term it was Gabriel, he was like head of this, and I think that Letizia, she will be, but I will make. I started now where I am not certain, so it sounds a little.
Do you contact Anna by which means?
With a mail, I guess.
Okay.
But I will check this before I like publish any recording of this, so that I don't start by telling lies. So,
yeah. Okay.
Okay, but when you have booked, then usually you book like an afternoon or a morning. Since these operations might take a very long time, usually you don't like allow for 3 different groups to have 3 different jobs in one day. So like you book a morning or an afternoon. And when you get here, let's see now so I don't mistake this. The x-axis is in this direction, and the y-axis is in this direction, and the z of course is this. So the y-axis might be like position here or in the back, or it might be anywhere. Right now it seems to be in its hard home position. And if I will look more at Carl,
that's fine.
But that's because he's so.
It's totally fine. Just to make it easier, the longer axis is the x-axis and the shorter is y.
Yes, and I've tried here. There's like a cheat sheet. Previously it just said x-axis, but I have tried to like point an arrow that it's this way. So somewhere around here, or it actually should be precisely below this spindle, is the machine's internal coordinates or origin points. Alright, so the x-axis and the y-axis. And to turn on the machine, you go to the back of the machine. And there are 2 switches, and both needs to be on for it to work. And the way I have learned it from Vasily is that you begin with this on the actual machine. So you just turn that to a vertical position, like a 1, and it's on. And then here on the wall, you do the same. And now you can go to the front. And this is the controller. This is like, where you control the machine, where you interact with it. You actually, the instruction file, the G-code file that you send to the machine, it's actually synchronized from a server. It's synchronized from this computer. So there's a local storage folder there, which is synchronized to the controller, and from there you can load your file. So when the machine is booted up, there will be a yellow warning sign on the controller which says machine not homed, and that simply means that the machine is booted up, but it doesn't know where it is. We see that it's here around the origin points, but it doesn't know where it is because it has been turned off, the memory has been purged, and So we will make sure that it knows where it is. And now when it is positioned here in the origin points, it will be a very short distance for it to home, to find its hard home. But it could be that the y-axis is on the other side, and then it will like slowly find its... so now it will not be the best circumstance for demonstration, because it will be just like... so to allow the machine to locate its hard home, press the blue shift key here, and you can see on the controller that's the shift icon there, that it lights up, and that makes sure that you can hard home with the hard home button here to the upper left. So now it's going to home. It does not have a hard home. So we'll try again with the shift key and with the home. And it says the same thing again, initializing Spindle. Nothing, what did it say there?
Homing aborted.
Homing aborted. Well, since the machine is unhomed, I don't know if it will accept a jog command. You jog the machine in the x-axis, forward here, or like further away with the 8. But since it's not homed, it will not accept a jog command. So right from the start we have a problem. Actually, it was like this million, not $1 million, but $100,000 machine. It just wanted a reboot. So
okay, you turned off the power and something.
One can only shut down the machine after you press menu and go down to shut down and confirm shutdown machine. So we can actually do this now. Do you have any rush, or like do you think it's okay that when such things happen, so then we can shut down the machine. And then we say to unload tool, and it feels that it doesn't have any tool, so it will not do. Motor drive disabled. Now it's okay to power down. It's very straightforward, because it's like the same way that we turn it on, but in the other way around. So Vasily has learned me that first this one, turn that to the horizontal, and then that one to the horizontal. Sorry, do you want to power down? Yeah? And here as well. Yeah, and Carl can do that too. It's like, this is like, I don't know what to relate to, but it feels like quite. And then, yeah, I can turn it on. So I can turn it on there. So we'll go back there and see. Alright, yeah, now we can see like how it boots up, and it loads the firmware, I guess, and then it loads the there's a, I don't know if it's called a plugin in this case, but there's a software which is called an automatic tool changer. And for this introduction we will not go into the automatic tool changer, but just so you know, Fusion 360, you can define several tool paths with different tools, and it can automatically change. So you only need to supervise it, but you won't need to do like a manual, like complete one tool set and then manually change, and then, yeah. Okay, now we are back here. The machine is not home. We press shift to activate this command, the hard home, or the machine's own home. I will see if this works now, or if it's every other turn here. Yes. It's timing home, and first Z and then Y and then X. And like you see, the movements here are really small, but if you would have like more, yeah. And then you were always asked when you boot up, do you want to run the spindle warm-up using tool number what? And the spindle warm-up, that is to make sure that the spindle, if it has been left unrunning or not run for a long time, actually I think it's like 4 or 8 hours. One thumb rule is that if it has been run previously in the day, you don't need to do a warm-up, but if it hasn't been run or if you're running it for the first time during the day, then you do that one. And without clicking here right now, we will now choose a warm-up tool. And the warm-up tool, the purpose of the warm-up is to warm up the spindle this one. So the actual tool that we use, it does not need to be, or actually rather more clearly, it should be as small as possible so as not to put another load on the spindle. So we can go back here and see what tools we have here. And if you, now it's, I see that it's good because here it says 2. But if you are standing in the front of the machine, then to the far right is a number 1. And then it's to the left then, or to closer to the over the switch is 1, 2, 3, 4, 5 and 6. And each 6, all 6 can be used in one run. But for most runs you only need one tool, or you have defined one tool. But it can be used, and with automatic tool change that is automatic. So to take out one of these, you can just firmly take that one out. And you can see that this is really, really small, so this is suitable for the warm-up. And since this is tool holder number 1, we can just reset it. We can attach it here, and it's once you identify it, it's quite clear because you see that there's like this collar, a collar here, and that collar has a corresponding geometry here. So if you make sure that that is aligned, I think it's aligned there, and then you just push. Like that. And I have seen Vasily, who has more experience, he just like does it really smoothly. But the main thing is that it's firmly there, and that is correct there. So now we know that tool number 1 is a small tool, suitable for warm-up. So we can press one here. So Arif, do you want to press 1? You can see that these they serve 2 purposes. So this one is the 1. This is the jog left as well. The jog actually is the Y positive. Yeah. But so you can press 1 and then enter to confirm. Okay. And then we'll automatically catch that. So that's the importance of attaching it firmly in the right place. And now it will, for 20 minutes, it will run like this. So if we start low, I think we can really go up.
It says it's 5 minutes or so.
Yeah, it goes 5 minutes at a low speed, and then and then incrementally it gets faster and faster, so that it warms up sequentially. Okay. So while if you are first for the day here and you have to do this warm up, it's a suitable time to like double check in the Fusion 360 software in your file what is the tool number that you have assigned, what is the diameter, is the diameter actually here, has it been lost over the weekend, so we can do that. It's both good and bad with Fusion, that everything is synchronized to the cloud, so that while you theoretically own your projects and you can like export the stock file and the toolpath as well, everything is like in Autodesk cloud. So, let's see. If I go back here and I go to the demo model and it loads, then we can just double check. So that's most importantly the tool number, because that's a really easy way to make a big blunder, or so to say. If you like have the correct diameter for the tool and all the correct length of the tool, and everything is planned perfectly, but if there's a wrong tool number, then the automatic tool change will fetch the tool that is in that number instead. So if you put your perfect tool in the number 1 tool holder, and then it's actually accidentally in and then it's accidentally here set as something else. But here we can see that it says here T1, and that means that this tool path, it's defined as the tool number 1. But one can double click and find out here as well, just double check that it's number 1. And it's really, really important. And if it doesn't say it can say, of course, number 5, but then you will have to load the tool into the number 5 tool hole. Okay, so but if you click select here and you click the one you intend to choose, you can just I said double click, but you can edit it. I think it's by edit tool there, and then you can edit, I would say, with the processor. Here, the number you can change. If you have already prepared your tool perfectly and it's sitting firmly in the number 2 tool number, and okay, it actually is easier to just change if you have the time, but you can equally change it here. But now it's number 1, so it's as we double checked, and it's like we would want. One thing I will do now, when when you double click on a toolpath here, there, you open the properties for it, and here you can change all the properties for it, and the tutorial goes through. It's like, it's okay. And if you have any questions, we can of course have a follow-up. So one thing I will do here, instead of using the toolpath that we actually used, we will try, because I stated in the tutorial that the feed rate, the speed at which the router moves through the material, it's for styrofoam it's good at around 3,750 millimeters per minute. But we can change this here to 5,000, like that. We can keep the spindle speed the same. It will, if you keep the spindle speed at the same but increase the feed rate, it will get more material per tooth. So it will be a more a higher load on the tool. But depending on the hardness of the material, it can be okay. Or if it's too much, then you will hear that it doesn't work. But you should always start slow, and then you can go up in speed to a speed which you find comfortable with regards to what you hear and what you see. So knowing that around 3,750 is more of a optimal value, we can still have the 100% set to 5,000, and then we can start at the lower. So I will do that, and when I press OK, the toolpath will I thought actually that it should recalculate, but since we did not change the stepping heights, the pass step, which would lead to another toolpath. We only changed the speed at which it traverses. Then it didn't need to regenerate, but we can, since it doesn't take that much time, we can click here under actions. You can generate, and it has a valid toolpath, but we can regenerate it anyway if you want to make sure that you have made a small adjustment and you want to make sure that it propagates. And then we can. Alright, so while that computes in the background, I will make sure that we can upload ug.home, not University of Ghana, but KTH. And you can see how the toolpath is generated here. And of course, different softwares, it's called the CAM software, so it's computer-aided machinery. That's CAM, C-A-M. And different CAM softwares have different techniques. Fusion 360 has this adaptive clearing, which works really good, because then you can take the either the maximum cutting depth of the actual tool. The tool has I can show you. Like every tool has. I was just checking with myself if it's correct or not, but then I realized that of course no tool extends its sharp flutes all the way, so that every tool has one part which is sharp and which cuts in through the material, and a shank or like a shaft where of course it doesn't cut, but if it's constructed in an adequate way, then the cutting diameter is within tolerance at least a little wider than the shank, so that if you cut deeper through the material than the cutting edge, then it won't lead to friction. But you will need to check this because some of the end mills have a wider shank than they have a cutting a flute or a cutting diameter. But I can't remember the original reason why I brought this out here, but it has generated again, so it's okay. Alright, so with that generated, we can go through actions and simulate, of course. And since we have already simulated this thoroughly, and we have not changed anything else in the feed rates, we can go maximum speed and look at the statistics, because now it says that with 5,000 millimeters per minute, which is too high of a speed for the styrofoam to be properly milled, because it will parts of the styrofoam will break off because the spindle is not rotating. It can of course be increased its rotation, but 5,000 millimeters per minute is too much. So we will begin the operation by reducing manually the feed rates to a more proper level. But if one would go at full speed, like full feed rates, then the machining time would be 13 minutes or 40 minutes. Alright, and we can see that it looks as we want, and we can then post-process, that's like exporting. And then, like the tool library, we will make sure that this Jose file, that it's also supplied so that we can use it. Alright, and one has to make sure just that the document units, you can change either manually here to millimeters, but it's easier to make sure that the units in the documents is millimeters. Okay, so we can post-process that, and this is the demo 001, and that one should have been saved here in desktop CNC. Perfect, and I just upload it to the intraweb or to the KTH server, and I will just check here. Now it's in its final phase of the warm-up, so now it's 18,000 RPM. That's a lot of RPMs, and it's 2 minutes left on it. So yes, and one can make sure that this is 12 millimeters in diameter. I think we have already done that. So that not only the tool number is correct, but also the dimensions of it. So just to make sure that it's 12 millimeters. And this seems to be about 11.5, which is within tolerance. That's of course depending on on your tolerance on your project. Alright, and this is 80. Yeah, one can actually identify. There's a point. If I understand things correctly, this is these are the like flute portion, the sharp flute cutting portion, and above here is the shank, which is totally smooth. But then there's like this small segment here, like you see, and it is not fully. It is not fully sharp all the way. Like here, it's smooth, but that's to evacuate ships. So if you move further down than this in a material, especially if it's like a small pocket or something like it's where it cannot extract, then you will have a problem. That is something to take into account. So now the warm-up is complete, and now we took the time to make sure that the tool number was set to 1, so we should set it in 1 as well. And that is something to take into mind because right now tool number 1 is the warm-up tool. So we can actually do that now. So now that the warm-up is complete, we can take control here again. And then we click menu here. And then we go down to ATC. So automatic tool changer. And then we can tool unload option. No, sorry, that was not correct. I guess that the best thing here, since we want to make the tool number 1, the tool holder number 1 free, and that is already there. If we would make the mistake, that's a grave mistake, like putting a tool in number 1 and then it doesn't know, of course, it doesn't, it's not aware of that. So we will have to get another tool, and then we can get the number 3, because then it will leave number 1 in the tool holder number 1, which we then can exchange, while it has the number 3 in the holder. So we'll press 3 here and enter, and then it will automatically leave that in 1. And then we'll take number 3. And then we can go back here. So since we need this slot, this tool holder, for our pre-calculated toolpath, then we can take away this and put this in 2. Alright? And then we can use this one instead. And to put together a tool, there's like 3 components. So let's see here. There's the there's a collet. This is the collet in svenska. It's spännhylsa. So this is the one which actually like produces the grip on the bits, on the end mill, which squeezes the bits. But there's also this nut, and there's the shank, the shuck. Yeah. So what you do is you find your end mill, which you have already defined in the Fusion 360, and which you have checked here or in the tool library, like and then you must just make sure that it says here, 12 millimeters, ER25. That's the standard for all collets. It just means that it's about 30 millimeters long, I think. Yeah, 30 to 35. Yeah. But you make sure that the diameter is made for the diameter of your shank, the 12 millimeters. When you have made sure that, you can insert it into the nut. And this is a little finicky, but it's like, I don't know, I'm not a beer drinker, but it's like a beer. You see, like you can, if you do like that, it's easy. Now it's planar. So to insert it, you find which way is most easier, and then you like do like that. I don't know, like a kapsylöppnare or like something like that. And it can feel like it's stuck, but if you just apply a little pressure, then it gets a little smaller, and then it's all right. So when that is planar there, we can screw the nut back into the shuck. Let's see here, and just a little bit, and make sure that it's planar. That is important. That is not oriented in an oblique manner. And then we take the end mill, and we can just make sure that this is like so. It was too hard. Yeah, but that is good. And then we insert it no more than 2.5 centimeters, somewhere around there. I can show you why. I think that I actually showed you before, or perhaps not consciously, but perhaps that I was not conscious about it. But you can see here that if you insert it around 2.5 centimeters, then it is securely attached in the collet. The collet will produce a squeezing effect on it, but you will also hinder it to move it here, because if you would insert it too far, then it can slide vertically when it's collides, when it cuts the material. And that was what made it so that Gabriel had to fix it for like 1 month, and it was out of commission. And that is why the actual reason why we didn't get the opportunity to do this last. Yeah. So let's make sure that let's not insert it too much. So like 2.5 centimeters around that. You don't have to be like, you can see that it's okay there and it's okay there, but just not too much. Okay, so back with the nut. I think this was too hard, yes. But that is good, okay. So we can just like 2.5, something like that. And then we can manually do a little like this until it's like fixed in position. But this is not a secure, this is not securely firm. So we will use this for the purpose. We'll use this here. So if you put the one which you have manually like just secured a little, and then you make sure that it's attached here as well. If you do, you know, the righty-tighty, lefty-loosey, if you do this in a right clockwise manner, it gets securely attached, like that. So now it's securely attached. And you don't have to overdo it, but if you do it this way, you make sure that it's stuck securely. And that is, and that is, yeah, that is a tool. Now the tool is okay. So, yeah, we find this like collar. We put it there. I'll put it there. Oh, sorry. Very good. We have it there. All right. So next part is the calibration of the tool. Because right now it has number 3 there. So we can start by changing the tool to the tool number 1, which is the one we're going to use. So still here in the ATC, in the automatic tool change menu, we can get tool and we can choose tool number 1 and press enter. It will always start by leaving its tool number. But as you understand, here's a very delicate matter that you do this like in the correct way, so that it doesn't try to, yeah. Alright, but there's our router, or there's our enemy, or our tool. And now we will calibrate tool. So this is still in the ATC menu. If you would not have been here in the ATC menu, if you would have the right tool from the start, you can press cancel, and menu, and go down to ATC like you are already here, and enter, and go to calibrate tool. And then it just want to confirm which tool you want to calibrate. It's a number 1, which we have. So press 1 or just enter since it was already there. This is the calibration plate. This is a magnetically, what do you call it, inducive, or like, this is like a magnetic plate. And I can actually see that it's very glad that this has been freshly made. Perhaps not freshly made, but this is in a way better shape than it has been before. So I guess that someone has redone it, or right. Previously there was this like wooden block here, which these were neatly fit into. Now it seems that they are fastened with magneticism itself. So this is a magnet. This is another calibration plate. You will not need this, like this. You will not need this right now, but you will need this when we set the surface depth and the maximum cutting depth. But right now we already have a calibration plate here. So as for now, what's this? Like this? Yep. But we need a magnet. This one we need. So this one needs to be safely and securely attached to the tool, like this. Why I choose here is because it gets really like nice and firm. If you like do it here, it can more easily slip off. And but if you do it there, then you have some and then we need the controller. So if you can take the controller there, if you want, you can take it out of the, or if you with the leg, you don't have to, of course. But I'm just thinking that you could, if you take it out like that, then you can walk around with it. And here, it's almost always easier, even if you have it in your hand like this, it can become confusional or like confusing with regards to which is the X direction and which is the X direction and the Y direction. So it's easier if you like always have it like that, or if you just hold it like this. So You jog with these green buttons here. So, so in the Y direction there, you can see I jog there, and in the other direction of the same axis, and in the X direction, or in the X axis, and like that. And you also jog with the C, with the height here. So you can press C down to go down. But like if you have like some sort of hand between there, and make sure that it's straight above the place here, like it should have been, because it like auto moved there. Then you can hold down the 0 key to auto set, and that will really slowly. Perhaps this was a little exaggerated for safety, but it's good to be safe. But I will actually go down a little now. So like with the C down. Oh, sorry, we're already in the. Yeah, I think we should cancel the auto. Oh, sorry. Yeah. I did the wrong way there. When I started to do the auto setting, it's like it went into this mode where it moved really slow, which is good for safety. And when I pressed cancel, I accidentally canceled the calibration process. So then you will return it to the tool number to calibrate. 1, press enter. It will move there again, and you get another chance. So now we start by having the C jogged a little closer. And then we can see that we can move it actually a little bit closer here. And now we can hold down 0. So now we hold down 0. And as soon as the magneticism, or like, I say magneticism, but yeah, as soon as it touches, then it knows, okay, I'm there. And it says, it's said here very shortly or briefly, it said that tool number 1 is calibrated. And then you can press cancel, and it is calibrated. All right. I think I will need to check my notes so that I haven't forgotten anything. The tool is now calibrated. We have done one mistake here, but it's not a serious one as yet, because we have not done anything else. So we should take off the magnet. Yeah, I forgot about that. But this is like really important, that because you see that this is here, and if one would have left it there and run it, then this would have spun around and it could be disastrous. So it's very important that this is securely attached to the top there. Sorry for that. Yeah. But it's better to learn from my mistakes now than do them yourself. Alright. And of course, if you use several tools in with your toolpath, you must calibrate all of them. But now, since we only use one, it's really easy. We calibrate one. Alright, now it's time to fix the stock on the table. So here we have the stock. And perhaps like you saw in Fusion 360, the origin point of the machine is here, but the origin point of the actual toolpath defined in Fusion 360, it was set as the stock top, like this point. Like in the x-axis and the y-axis, it was on the most forward, most leftward, and on the top point here. So this is the soft code. This is where the toolpath will begin, so to say. The machine will know that its own coordinates start there, but it will work with this as the home for the job. And one can fixate, one can have this like anywhere you want, but depending on the material and depending on the placement of these vacuum inlets or outlets, because this is a vacuum bedded machine, so it's like really state of the art, because otherwise you would have to clamp the material in any way. But now, since we have the vacuum, which you just access inside there, when you open the vents here, it will get suction and it will get really firm. But you, of course, if you put the material here, then there will be no suction. Yeah. So you have to make sure that, okay, here we have suction and here we have suction. And then we can perhaps make sure that's okay, somewhere around here. And then it's, because the bed is this like rectilinear grid style, you can of course make sure that it's like aligned through the grid as well. So somewhere around there. So I can just make a note that okay, it's one grid block from that, and it's one grid block from that. Alright. And then we prepare with these, which we're already left here. These like insulator plastic, they make sure that the suction does not escape from outwards the material, so that the material gets fully suctioned. So we have it like the material is here, so we can make sure that this is here. And it's okay if that's not perfect there. And how, I think it's okay if we do like this. And this is something to like, you can either be very systematic about it and nail it on the first try, or if you just like try with one there and then reposition the material and see. Okay, so there was very settled. Yeah, but it looks good, because then you've got a nice suction there. So, alright, and these are over here. There are a lot of them.
Okay.
Yeah, I think that previously I who like ordering things, I like them there. But, oh. It was very long, but it's okay. Okay, so we can make sure that this gets something like that. And one thing to note as well is that we don't need like perfect suction on all the stock, just the part where we are actually cutting. So here I will make a corner, because we don't need like perfect suction over here, as long as this part where we actually cut is perfect. So, alright, something like that. And these are constructed so that when they meet, you can create like an interlocking meeting, so that you, if you go down around that corner and then go around that corner. Yeah, and actually, since this is so long and it's like all okay, I will make it the other way around. Like that, and like that, and like that. And this I can just here, but then it can be like that. Yes, it doesn't serve properly. And now we have, like you see, this area will get suctioned by these two inlets. And when we put this here, and it was one grid there and one grid there, so yeah, like this. Alright, then we can test out the suction. The vacuum pump is over here. And you turn it on with the black button here, and it gets loud. Alright? And previously, there were, perhaps if I have the time, perhaps I'll make them, because those are really nifty and handy. Because the vacuum suction system is not like, it's not perfectly, it has some leaks, and one can fix those leaks or diminish those leaks by having material which covers this, like small thin cylinders, which usually there were like for each hole here, a metal one, but they get really easily, when you are done with the machining and you are cleaning up, they get very easily sucked up in the vacuum as well. So I can understand why you know here, but I see that here we have. So yeah, one could like put these in. Yeah, you could hear that it's and now it's stuck here. So it's that's if it's really stuck, then after you turn off, it will get really easy. Okay, and I can still demonstrate with. Okay, now I can't demonstrate, but we can demonstrate with this because right now this is moving, and we can see here that this dot, this red dot, it serves which quarter or which quarter of the area is served. And if we go up with this, you saw that it's like, and I don't know the like perfect amount of suction, but if you test out, like if you test, this is it feels good. Yeah. And then since I might be inclined to do that, I can, if it was good, I can do a little more, but not like that much more. Yeah, I'm confident with that. Alright, now we have the stock fixated, and the next task is then to set the surface depth. And that we do by pressing cancel here. We cancel the APC, we cancel the main menu, and then we jog all the way to the material here. So we can first go a little with the y-axis, and then with the x-axis. And one can see here that depending on the length of the end mill, the maximum height possible for the material is not that. One has to take this into account. But if the material will be this high, then one could not use that bit. All right, but now it's on the here, and now we do this. So now we take this one, put it on the surface, take the magnet as well, put that here, and then there is this button here, the blue button with an end mill and a line, and that is the surface. And each different tool has a different surface depth. They all share the max cutting depth, but one will need to set the surface depth. So tool number is 1, that is correct. We can press enter, and then we can do like we did before. So jog it a little down. Oh, sorry.
Can I do it?
Yeah, of course.
This
yeah, of course.
Sorry.
Oh, stop there. So, and then you can press and hold the 0.
Yeah.
Perfect. That's really good. Right, so now we have set the surface depth here. And since the next thing we're doing is setting the maximum cutting depth, we can actually keep the magnet on and keep this as long as we just put it here instead. So we'll jog a little to the left here. And make sure that this is positioned correctly. Yeah. And then it's the maximum cutting depth is this one. So you press that one, and then it says setting maximum depth, and you go down, press there, and hold 0. And it says maximum depth set. Perfect. And then we need to remember to remove this. So let's this one. And this one. Alright. There's one thing left, I think. I hope so at least. And because now we have the surface depth, it knows where the edge of this end mill is supposed to meet here. It knows that it should not be cutting further down than here, but it does not know where this is. So we can jog So, Carl, do you want to jog to the origin point of the soft hole? Yeah, exactly. With that one, you. And then if you jog down with Z a little, then you can do like this. You can, if you look across the axis, and then if you position this so you like see through the hole. Yeah, I can do it like this. I want you to position this end mill right on top of that. So in this axis should be following or aligned to that axis. And if you want, you can go down a little just to see that you're like perfectly. Yeah, and here you can see that it's a very good. And here you can actually go a little more closer to you. Yeah, that's good. All right, because then, yeah, it's okay. Then we can do. All right, let's see now. This is a soft home. So since it's a green one, you press shift and you press that. You set home to 1. Now your number 1 home is set. You have the number 1 home, you have the number 1 tool. You have everything prepared for running it actually. I'm just going to make sure, this is also because when you are here, you can of course call me or like anything. I'll be glad to be here the first time you run as well. But right here, everything I have said, there's like nothing that doesn't say here. So you can just see it. So we have this here. We have started the machine, we have calibrated tools, we have turned on the table vacuum, we have set the surface, we have set the maximum depth, we have set the soft home. Alright, this one is in parentheses because it's automatic now. So you don't need to do that. Now it's started job. Double check that the magnets are here. Yeah. Alright. Because then we can go to the computer. And I don't know where we were precisely here. But if here. We can see here that the demo 001 NC file, the NC file is a G-code file. So it's just pure text file, but in a language which the machine understands perfectly. Coordinates simply, and some basic instructions. Alright, so here's the thing. On this particular computer, there is one folder which is synchronized to the machine. As long as, if you look into the task menu here, there's a machine tools widget here, or what you call it. And for the job name server, you can see that it's online. And as long as that is online, you know that it communicates with the machine. You can minimize this. Alright, and then we can just copy from our user account here to the, on this particular computer, in the OS disk, in the C drive, there's a folder called DNC files. And here, like everyone has their own, when Sophia and I did it the last time, we just had moon and grounds. So we'll put it here as well. We'll paste it here. So now we have the file here. We have the demo underscore 001 NC file here. And once we see that, or once like we know that it's there, we can go back here. There's this little icon here which says that it's online, it's synchronized. So every file in that folder and their subfolders should be synchronized here. And we can press that button. You see that the one with the CNC bed and the computer. and we're in Gabriel's folder. To go to the top, you can either go jogging like this, or you can press the C to go further up. And then enter to confirm. And then you can press set down to go down here, Northern Grounds, and go down as a demo _021. So it's synchronized. And enter here. Yeah, if you press enter, it loads the actual toolpath. And then you can see that, oh, but I recall this. This looks like actually something that I might be responsible for. So that's if this looks like way off, that's a warning signal. Perhaps you should like check in Fusion 360 if it's like, but this looks like what we actually are looking for. And so that was enter to enter the preview. But when you press action, you are ready to send it to the machine. And just a quick safety check, like we have the vacuum on, we have made all those arrangements, we have that here. Do you think we're ready?
Yeah.
Yeah? Okay, yeah. Then we can go out. And before we even start, this is the emergency button. Everything is shut down. So, like if something happens which abruptly needs to be like at the same moment stopped, it's this button. If it's not an emergency, but you find that like, oh, perhaps like the feed rate is a little too high, and I want to think about what feed rate to adjust it to, then this pause button is the button to choose. If you pause that, then it will get paused. But one thing to recall, I think, this is not, we can test this out of course, but I think that it's the actual feed which gets paused, but the spindle is still rotating. So that's one distinction that I think is the distinction, but we'll test out that of course. All right, and before we even start as well, to the left of the Z jogging is the feed rate, adjust up and adjust down. And the feed rate will always start at 100%, and 100% is the feed rate that you set in Fusion 360. And now you remember that I intentionally increased the feed rate a little so as to be able to decrease it and like test out so that you get the feel also like when it sounds good and when it sounds not so good.
Okay, so you can't go over 100 in this.
Exactly. Yeah. So if you set a far too low feed rate, then you will need to go back to Fusion and like redo it or like recompute, set a new feed rate and recompute. But if you are intentional and aware of that you are like perhaps starting at a feed rate that you have not tested out yet, then you can, as soon as you press execute, you can decrease the feed rate, and then you can like push it up sequentially and feel the material so that it doesn't start at 100% at way too high. Yes, but with the RPM, with the speed, the spindle speed, you can always increase it or decrease it how you want. One thing to just reiterate or like to remind you of is that the one thing that is actually essential for the quality of the cut, it's not the feed rate only, it's not the speed only, it's those two combined which defines the ship load per tooth. How much material each flute actually has to cut through the material. If that gets too much, then the whole machine will have trouble to move through the material, and that's really not good. If it's too little, a guideline when it's wood, now it's a very soft material, styrofoam, but if it's wood, it should always be wood chips, not sawdust. Because if it's sawdust, then it's going too fast. Like the spindle is of a too high RPM, the ship load is too little. That will make excess temperature. It will increase the temperature. You will have a risk of fire. Yeah, you don't want that at all, because it's like a spindle, a piece of carbide steel moving around its own axis at 18,000 rotations per minute. that's friction if not handled carefully. But now, since we have talked about the feed rate and the speed, the spindle speed, we can actually start. And the first thing I will do is reduce the feed. If you don't have a question.
No, that's what I was going to ask that. If you reduce the feed now, reduce the feed rate now.
Yeah, immediately. Now it starts since the actual spindle is positioned like in the origin point. It will very quickly get to business. Mm-hmm. One like quick fix or one method of diminishing this is to simply jog. Sorry, we're in the, so I will cancel this. And with this cancel, we can jog again. And I will jog away from the origin point so as to buy us a little time to decrease the feed rate. Because if we will start at the beginning, then it will be like, oh, I'm ready, and then it will go, yeah. But if we move a little further, and we can with the set as well. Okay, like that. And now we repeat again. So we press the server button here, and we press enter to preview this. And we can see that this looks like what we want. And I might not have stressed that enough or like put enough emphasis on it. But you have to, of course, make sure that the actual stock point, the actual point on the stock which you now use as a soft home, that is the same orientation as the stock point in the Fusion 360.
Yeah.
So yeah, but it's like, it might be obvious, but it's really important so that it doesn't like start one whole unit or like. Yeah. All right, then we're ready to execute this. And the first thing we'll do after pressing once again on the execute to start the operation is to reduce the feed rates. And now we reduce it to 60%. Mm-hmm. So Arif, do you want to press the execute button?
Yeah, I can do it. And then just...
And then now I can, if I, now I just hold down, so it's 80%, 50, 70, 60, and now 68, 65.
Yeah. It's fast.
Yeah, so now it's more than 64%. And you could also hear that this is like, it's, it sounds not that good. So you can decrease the RPM a little. You hear that that's another sound, or about 500 RPM, so it's a little lower sound. And we can change the RPM even more, so we go down a little more. Yeah, and you hear that it's another sound, and you will have to standing here on the other side of the glass might be that you're at such a distance so you don't see like the surface of the material. But anyway, somewhere around, and if we increase the feed rates to about 75% now, but still have the RPM at 7,000, then comparatively the ship load per tooth will be higher than if we would also increase the RPM. But from here, I can't say that I can see the result and like evaluate the results. But it looks like it does its way in the way one would expect. Yeah, and there one can see when one is working in really soft material like styrofoam, it's really good if you're like doing your first CNC job because it's really forgiving. But also you might have seen that like thin shapes like that, they just flew away. If you're doing this in wood, then of course there would be more rigidity to the material. So,
so isn't it better kind of like if you are using a soft material like styrofoam? Isn't it better to use thinner blades? I mean, thinner.
Oh yeah, I understand. So as not to exert that much force to the. Yeah, I would say so. Now there are two reasons why still shows this 12mm diameter bit. And it was
that's what I'm gonna ask. What's the reason behind?
Oh yeah,
this 12mm?
Yeah, the wider the diameter of the bit, the more area or the more surface area of the material it can cover in one go.
Yeah.
Because if you're going for a thinner diameter, then it has to backtrack several times to cover the same area.
Yeah.
So one is a time.
Yeah.
This one, it said that it should take, like the preview, it said, I think 17 minutes.
Yeah.
Which is like perhaps in real time, it can be like 20-25 minutes. And if one would have half the diameter, I don't know if it's proportional, but I would guess that it's double the time.
Yeah.
But,
Yeah.
do you think of anything, or? Yeah, and this part, it might be a little tedious, just like looking at it, but it's important that you supervise, because things can happen, and like if you have done everything correctly, which one should make sure that they should, then since the maximum cutting depth is set, it cannot extend beyond that, so it will not be a problem, even though like the softest thing, like if it would be inches instead of millimeters, and it would be way off. If you have set the maximum cutting depth, then it will not extend past that anyway. If you have not set that, then it would like extend through the board, and that would break the bit definitely, and damage the board or the bed most probably. This feels like something that we will know the results when we come in with the vacuum and post-stop.
Yeah.
Do you have any questions, like, because now would be a good time, like, for any questions, not related to anything or anything in particular?
It's good. It's doing good.
Because I can understand if it feels like a black box initially, like, okay, this worked, but how do we know that it works for us? But you know, you can just ask, and I can double check. If you are using Fusion 360, it's very easy for me to just like look at the settings, because Fusion 360 is quite user friendly in a way, and most of the settings it like auto adjusts. If you adjust that parameter which is related to that, it's auto adjusted as well. But I think that you are perfectly correct that this geometry would and this material would be better with a thinner diameter.
Yeah. But what do you call it? It's not a blade, right?
I call it like interchangeably a bit, or a router bit, or an end mill, or I think those were present. So.
Yeah.
Yep. It's finished. It has returned the tool over there. It has released the tool into its original tool number holder. We can put this here. And before turning off the vacuum or doing anything else, we will of course clean this up. And it's very easy to make a larger mess than originally was, because you get so it's good to as fast as you can start with cleaning up, so that you don't do like that and like everything goes everywhere. Yeah. Okay, so we'll use this one. We'll take one of these. And let's hope Manfred does not see it. He would really.
It's
a little dirty, but I guess it's no problem. Alright.
Alright.
Oh. One should not underestimate that this turn takes quite a long time, but we try to do it Okay, so now everything is cleaned up and we are ready. Now the vacuum is still on here, so we can go down, what's it called? Turn that clockwise down, make sure that that's the case for all. And then we can lift this up. Yep, it's free. And it's like, it's not fantastic, but it's what we expected. So,
Yeah.
and this one can then go into the assembly room and then just with the hot spring. All right. So we have switched off the vents here, so we can go and turn off the vacuum. Red button. All right. And we have to shut down here. It can be a little like tempting at when you're there. And here it's menu, and this menu setting called shutdown and confirm. Do you want to shut down the machine? Everything looks good. Tool is in its place. It's clean.
Just a question. So after finishing the task, should we return the head back to here?
No,
or?
it's actually it's better if it is over there, because then it will like move. I think that the problem was not such a grave one, not such a serious one, because we only restarted and then it worked. But I think it was partly due to the fact that it was over here. So it could like, I have no room to move. I don't know where I am, and I cannot move in the direction I want. But there, it's yeah. So we can confirm to shut down the machine. Yes. And if the tool would have been loaded, it's unloading, but there is no tool.
So it unloads automatically.
It unloads automatically. And it can be changed in the settings, and but as it works, it's good.
Yeah, I guess
It's okay to power down. You can just like focus the eye on that. Okay to power down. And there we can power down. And I guess this was first. So like that. Right there. And all the noise is gone. But great work, and thank you also, because I understand that there was some some parts of this that were not like in the curriculum. Manfred arriving, me checking back, and like so thank you for your patience as well. Do you have any questions about the workflow?
No, I don't think so.
No, and like Anna suggested, and like I wholeheartedly share the pleasure in, when we will meet again here, when you make your cut, and I will make sure that that you don't have any answers unquestioned. What do you call it? I might not have the answer for it, but I will make sure that you are not here and alone and don't know whom to ask. And, yeah.
Nice.
Great.
All right. Thanks a lot.
Thank you.